Hello friends, welcome to day 20 of 21 days of code with Ozone. Today here I am with first problem for the day, and the problem name reads as minimum ASCII delete sum for two strings. And the problem reads as follows. Given two strings S1 and S2, find the lowest ASCII sum of deleted characters to make two strings equal. Now, what the question is asking is that we need to return the ASCII sum of the minimum values of characters that we need to delete from either of the two strings so that we can make the two strings equal. And now moving on towards the example number 1 reads as S1 is equal to C and S2 is equal to eat. So how do we make these two strings equal? So basically what we can see here is that the two characters E and A are common to both of the strings, but character S and T are exclusive to either of them. So what we need to do is that delete S from string S1 and T from string S2. That leads us to ASCII sum of S is equal to 115 and T is equal to 116, and on adding them both we get 231. So we return 231 as answer for this question. Further moving on towards example number 2, given S1 is equal to delete and S2 is equal to delete. Now what common string can you see amongst the two? So as you can see here is that we are having L here in this string and this string, E also here and a T here. Apart from these, I don't think anything matches in the same sequence. So we need to delete D, E and E from string 1 and E from string 2. So the ASCII sum we have here is that 100 plus 101 plus 101 plus 101, that is D plus E plus E plus E, which gives us 403. So the answer for this question is 403. Now you might get an intuition that this problem is a DP problem. What we'll do is that we'll develop a relation between the incoming character and the previous input, and based on that we'll compute our sum. So we'll just have a rough idea and then straight away move towards the code to implement it. So what you can see here is that I have made it DP matrice and also written the values after each stage of operation. So what we'll do is that we'll go through each and every step and match it with the return value so that you get a clear understanding of how the algorithm is working in practice. So what we'll be doing is that we'll be filling the last column and the last row with the substring sum starting from the last index. So starting from here, this corner column will contain value 0. So this block will contain the ASCII value of last character of S1, that is 97 here. 97 here if we tally from here. Then this block will contain ASCII value of A plus E, that is 97 plus 97 plus 4, that is 198. Similarly, we'll add S to this and filling in this block with the value 313. Same pattern goes for the row that we have occupied here. So this value will contain, this cell will contain the ASCII value of T, that is 116. Adding ASCII value of A, that is 97 to it, that results in 213, and adding E to it results in 314. So that's how we filled our last column and last row. Now this was the pre-initialization condition that we need to satisfy. Now we'll move on towards the actual code part, in which we'll be filling this 3x3 matrice in a fashion such that we'll be able to compute the minimum ASCII delete sum. So what we'll be doing is that we'll be starting from this block and we'll be checking first that whether the two characters are equal or not. As you can see, A and T are not equal. So in the case when they are not equal, we'll be using a simple formula. The value at index I, j, here in this case it's 2, 2 is equal to math.minimum of value of index I plus 1, j, that is this cell plus code point at I. Code point at I returns the ASCII value of the particular character at that particular position. So it would be minimum of this 116 plus ASCII value of A, that is 97, which computes to 213, or the minimum of this value. This value is 97 plus code pointed J, that is ASCII value of T. So out of that, which one is minimum? So surely 213 is minimum. So we fill in 213 in this block. As you can see from this output also, it's 213 here. Moving on further, what we'll be doing is that we'll be eventually filling up all the blocks in the same fashion. Now the next condition will be to fill this block further, this block and this block. So this block, the value of I is equal to 2 and J is equal to 1 here. So in that case, we'll simply be using this formula again because the characters are not matching, and we'll be filling in the value here that is equal to the minimum of these two conditions. So we compute the value that is 198 will be coming up here, as in this case. Moving on further, at this point, the value of char at 2 in this string, that is A, and here 1, that is the value at 2, 1, that is this block, and the two chars are equal. So we'll simply copy up the value at I plus 1, j plus 1 here, that is equal to 116. As you can see, this is diagonally related. So we fill in this. Similarly, if we move on further and keep on filling this, so basically what we'll be doing is that storing the result of previous state in our DP matrix, that we'll be using it to compute the further values. And based on these two simple conditions, that is, if the incoming characters at particular positions are equal, we simply copy the diagonal value, and if they're not equal, we'll use this formula. So I hope the idea is pretty clear now. Now let's move towards the code and implement this. So this is a lead code ID. So first off, what we'll be doing is that we'll be initializing our DP matrix. The dimensions are equal to s1.length plus 1 and s2.length plus 1, as we have already discussed earlier. Now we'll start to fill these values. So last column and last row, remember. So this is the condition for the last column, and we'll simply be filling the values. The column is fixed, so we'll just iterate over the row and fill in the values. And similarly, what we'll be doing is that for the last row, we'll be doing it in a similar fashion. We'll be filling up the last row and the last columns, as we have already discussed. So now moving towards the main part, what we'll be doing is that we'll be iterating over the complete lengths of the given strings. So for int I equal to s1.length minus 1, that is the length of complete string s1, and I is greater than equal to 0, I minus minus, that is we're iterating over the s1 string. Similarly, nested iteration over s2 loop will add as a supplement. So we'll use a variable j for this purpose. Now, if the characters at position I in string 1 and position j at string 2 are equal, as we have discussed, we'll copy the diagonal value as it is. And if they're not equal, remember the DP formula that we have discussed earlier, we'll be using that. DP at I, j is equal to math.men of DP at I plus 1, j plus s1.codePoint at I, or DP at I, j plus 1 plus s2.codePoint at j. This is a complete formula that we have already discussed, as you can remember, and if you don't, you can scroll back a few minutes earlier where we discussed it on the whiteboard. And at the end, what we'll be doing is that we'll be returning the value at index 0, 0. That's normal in case of a bottom-up DP approach. Now we'll try to run this code up. Okay, looks cool. Now we'll try to submit it up. Perfect, it works as expected. Thank you for watching.